Hello and welcome back to the virtual observatory. In this tutorial I'm going to talk about brightness temperature collocations. So we go back to the main data selection page, and the default ECV selected is already brightness temperature. We're going to use GRUAN radiosondes. Now you may think, brightness temperature from radiosondes, how does that work? Radiosondes normally record in situ pressure, temperature, humidity, but we use a radiative transfer model, the RTTOF, to do a forward modeling of this pressure, temperature, humidity profile and convert it into a brightness temperature along the flight path of the sonde. Now, why would you want to do this? Normally, if you do a forward model, the uncertainties are better defined, they're smaller than doing the inverse, taking a brightness temperature value from a satellite with the inverse model to retrieve a temperature or humidity profile. So you're actually better off, if you want to validate the satellite observation, to convert the radiosonde into the brightness temperature, not the brightness temperature from the satellite into geophysical units. Within gaia-clim you can read much more about the so-called GRUAN processor that does this. Now, on the satellite side, we have the Hertz instruments on a couple of satellites. We have METOP A, B, and 119. I might just choose METOP A. And then, of course, above the explosion altitude of the sonde, the atmosphere doesn't stop, so you need to fill it in with some NWP model. We have the option to either choose the UK Met Office or the ECNWF model. Let's just stick with UK Met Office for now. The differences are very small anyway. And maybe we reduce the selection criteria a little bit, be a bit more picky about the collocations because we have lots of them. So we might reduce the distance from 500 to 250 kilometers, and instead of 6 hours, maybe we just allow 120 minutes, 2 hours. And that'll bring down the number of observations substantially, a bit quicker to plot. I might just pick the GRUAN Lead Center in Lindenberg, which is a suburb of Berlin, and just send the data request. Also, you can see here now by default it's ticked the cloud-free only, because in particular the humidity profiles, the temperature profile are affected by clouds for the Hertz instrument, so you're much better off only picking the cloud-free observations. To the radiosonde, of course, this doesn't matter. They fly, rain or shine. I might just close this one so we can see the plots a little bit better, and we can see a pronounced annual cycle. Here on the y-axis we have brightness temperature, typically between 210 and 235ish maybe, and from 2013 till almost 2017. We see in blue the Hertz instrument from the satellite, so each little cross here, each little dot is an observation with its error bars, and then we have the GRUAN radiosondes with the ECMWF model here. Funny, because I thought I'd chosen UK Met Office. I think that might have been reset when I chose a smaller distance, so that's a bit of a bug. We could go back, we can do that in a moment, and pick UK Met Office for a change. And then we have on the right hand side the difference between the two, and now difference here are plotted in percent. And we can see they're quite evenly distributed around 0, so there's no strong bias either side. We can also see that already in this plot here, because if we look at the mean values, the average values for Hertz and GRUAN, then we have 220.75 for Hertz compared to 220.57 for GRUAN. So there's a 0.2 Kelvin bias, which is it's reasonably good for a validation. And then on this side here, we can look at the individual collocations and how they spread. As already mentioned, in the case of ozone, with the full error budget is not known. It looks like the the spread is larger than the known uncertainties, which should not be the case in this project. But then again, we do not have all the error components, and that is because although the GRUAN radiosonde has every error budget conceivable well documented, once you put it through the radiative transfer model, of course that doesn't apply straight for the uncertainties. So you would have to do a Monte Carlo study and vary parameters systematically, and then see how does it affect the brightness temperature. And that was beyond the scope of this project to do. It's something we would have to do in the future to get the full error budget for the GRUAN sonde in brightness temperature space. Also, you can here on this side, you can see at the moment we're looking at channel 2 from HERS. HERS has 19 channels. The channels 2, 3 and 4 are temperature sensitive channels. So if I change to channel 3, then this picture will change slightly, but the agreement is similarly good. But if we were to pick channel 11 or 12, they are sensitive to the retrieval of humidity. Then we'll see that the agreement generally will be somewhat poorer. We have larger biases. So just if we look at 254 compared to 257, so 3 Kelvin, roughly difference or a bias between the two data sets. That's just because water vapor is harder to do and has a higher variability, much smaller scales, so it's a lot harder to do. We can all see here in the error budgets that not only do we have some outliers, but also there is clearly a bias between the two data sets. Yeah, I might just go quickly back to fix. You can play a little bit with this data. Now when I chose here the smaller difference for the co-location, so when I made the co-location criteria more strict, now this should have, oh, that's a bug then. So I thought I had maybe by accident chosen ECMWF here, but that's not the case. We could pick a smaller date just so you see how this feature works as well. So maybe we could just pick a year worth of data from 1st of January till maybe 2016 December 31st, and put that in. Yeah, and then we can see in channel 11 we have that clear bias, but if we go to any of the temperature channels, then the green is actually pretty good. Yeah, and that was all I wanted to show with the brightness temperature files here, and I hope to welcome you back to one of the other tutorials.